everybody, today I'm going to be telling you how ROM works. As you can see, I built a ROM. I'm going to be explaining you each and every step on the way, and I hope you enjoy the video. Like and subscribe, and let's get into it. So our first demonstration is over here, where this is the simplest form of redstone you can get. Some people might classify it as ROM. It's not really ROM. It's not ROM, but some people classify it as it. So yeah, you can only read that this or this. Basically, that's it. You want to read? That's it. ROM stands for read only memory. So that's why I've put it there. And then so that's why we have 5 bits. We don't want to have 26, that's really inefficient, and a computer can't handle that. So what we do is use normally 8 bits, but I'm not displaying capital letters, which are normally used for the first 3 bits, like 011 for lowercase and 010 for uppercase. So, but apart from that, that's basically what the first 3 are used for. So here's a simple 5-bit demonstration. And so you use ASCII characters. So 1 and 2, and in binary numbers are 1, 2, 4, 8, and 16. So the first letter alphabet is 1, so A. And before that, 0th letter space is, or nothing, is space. So 1 is A, 2 is B, and then 2 plus 1 is where we get it from. This is 3. And then you can jump over to here, because 4 is nicely coded. 4 plus 1 is 5, which is E. Then you get 6 and 7. And that is basically how it is. So let's move on to our next demonstration, a small scale version of what I have over here. Now wait till the end to find out how it works. So as you can see, what we have is 4 ways to input this. I like to color code it because it just seems nice. I use grey for the extra parts, which it can be and I use orange for the line down there, and then I use red for the line up here. So so this is a demonstration of the letter A. So if we input A lights up because A has a torch in it and the rest has repeaters. So if we put anything, if we don't have it on, this will light up and stop it from that. If we have it on but we have something else on, here's where the clever part comes in. This repeater stops this by locking this into place and then not allowing this to glow up. So it only works if you have the correct combination. Even if you do something that's not in the even if you do the 17th letter of the alphabet, which I believe is Q, so yeah, it still works. That's basically what it is. So how about we can finally get onto this masterpiece. Usually decoders are stacked side by side, but I managed to compact it with only a 1 block gap in the middle. This isn't 100% always correct, but it works. So this is a ROM, a bit complex, 5-bit ROM. So as you can see, A is encoded here, and I like to add repeaters in the place even if it's not, just to make sure it goes at the same time rather than flickering between different ones. It's more clear, and also so that it actually goes longer distance. So let's see how A is encoded. So A is encoded with a torch because it's the first letter of the alphabet, and the other ones are not really encoded with that. So let's go on to B, shall we? As you can see, they're all the same. I should probably go into spectator. Okay, here we go, B. as you can see, B has only one with a torch, which, wait, if I can get to B, which is this one, and all the other have repeaters. The reason why we do the torch, even though you can just do repeaters, is usually because you get it more than here and it would mess up the redstone. But in this build you don't really need torches. I just like using them. Actually, you do need torches. Actually, yeah, you do. So that is B, and let's move on to C. Now here's where it gets a bit tricky. You have to code both of them. It's not like, oh no, I have to code in between. No. You have to code both of them. That's what most people mess up. And over here you can see it's just a lot of, these three are just, you know, these three are, you know, just all runs out, basically, kind of. Yeah, and they just go down. The common theme on this level is these two aren't used on this level, so I think we'll go to this, focus on this side. So A, B, C. Now here's D. You have to move along in the alphabet. So with 1 bit, you can only represent, with a 1 bit demonstration, you can only represent 2 things, A and nothing. With 2 bits, you can represent nothing, A, B, and C, 4 things. So it's just because you do, yes, with 2 states per thing, and then you can add a combination. So this has 2 states, this has 2 states, this off is the same as that, so yeah. It's a bit confusing, but that's basically how this entire RAM is coded. Now, I done something different. Although most people would make it on go forever and ever, that's a bit, you know, not so compact. I want it compact, easy to reach, probably, but it's not really easy to reach. It's hard to navigate. But yeah, it's like a maze in here. It's hard to find which one's which is why I made it like this. It's simple to find everything. I done a 7, 6, 6, 7 layout with an extra space one here. And then if you want to do a something that's not in these, you can use the extra reserve spots, because Z is the 26th letter of the alphabet. So 16 and 4 and 2. No, not 4. 8 and 2. Sorry, 16, 8 and 2. That is Z. Now there is more than that. You can code 27 to be maybe hashtag or something, or you can code 28 to be something else, 29 to be something else, 30 or 31. 5-digit representation goes up to 32, because you have all on and all off as well. Whilst if you talk about combinations that are not all the same, you have 30. That's just a simple thing. The more you have, the more combinations you have. And normally the first, and you can even make customized, you know, bit stuff. If you want less characters, you can just remove this or one of them. And if you want more characters, you can just remove one of them. So, you always have to remove the one on the left, because it starts on the right. Like, I'm getting 1, 2, 4, 8, 16. So that is basically how binary works. And the ASCII demonstration, and how about I show you the ASCII demonstration. The ASCII demonstration normally uses the extra ones for showing capital and lowercase letters. So how about I show you that? In the meantime, I'll talk about how ASCII works. Normally, in computers, it's predefined whether it's an ASCII character or an actual number in some computers. I'm not 100% confident on that, but I think that's what happens. So ASCII is just it's the character set we use. So A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, R, S, T, U, V, W, X, Y, Z, #/, and there's also Japanese ASCII and Chinese ASCII, but I'm not going to talk about those because I don't know them. So let's show you what lowercase a would look like. A normal 5-digit code A, then you would have these extra 2 at the start. A capital A would remove this 1. And you can code these to be whatever you want. I don't know what it is, but this could be so you can have the far left one, but normally the far left one is a 0, so the computer doesn't get it mixed up. But you can have it 1, like I had it there. So 10000 can be a something else, and it'll be in the ASCII character set. I know I'm talking a lot, and this may sound a bit nerdish to you, but this is what you have to understand to get into binary. Binary is all about the ones and zeros and what each combination represents. You have to be good at math to be good at binary, because the only thing binary does is 1, and then let's say 4. That is 5. What's the 5th letter of the alphabet? E. So literacy and math is used a lot to use binary, and that is how you can use it to code a computer. But what is read-only memory? So let's say that I have some memory, right? How can I read it in a way? That's the problem. How do I read it? Everyone wants to, let's say people want to read it, but there is no, way to read it. So the way it works is you use pre-stored characters from the hard-coded character set, and hard-coded means it's implemented straight into it. It's not like, doesn't use any internets and not soft-coded or anything. It's straight hard-coded into it. So basically, that is what you have to understand, and the way you do it is by just assigning each one to each one. ASCII is very important. You can use other character sets, but I don't really know them. But ASCII is the most worldwide to use, as it is what we use on our keyboard. Most letters on our keyboard is a part of the ASCII character set. Some letters aren't, like numlock or control or Windows, but most are. And what is ROM? That's what I was asking earlier. ROM is, if you read the memory, you want to have memory, but you need to read it. So you ask your ROM, hey, can I have this? You use the ROM. It's generally encoded in an SSD or a hard drive. An SSD stands for soft drive. So it says, oh, what does this stand for? What the ROM will do is say, okay, this stands for A, and it will send the A to this computer screen with what we use as a 180 HP resolution screen. However, for setting out most ASCII character sets, all you need is a 16-segment display, which is what most old things use, which is like a big square with with all of its lines of symmetry in there. That is basically all about ROM and how to understand it. I hope you understand what I said. in case you didn't, leave a comment in the description below, and I will go out of my way to try help you understand this stuff, and hopefully I'll see you in the next one where I'm doing RAM. And this took a long time to build, so which is why I haven't been uploading in a while. So please understand that it's taken a while, and hit that subscribe button, and no, I haven't gone dead.